My name is Petyo Dimitrov. I'm a senior software architect at Musala Soft. And for this session, we want to do something quite ambitious. For 20 minutes, I want you to exit here by having a good overall understanding for NFT and also some technical insight, which for 20 minutes is quite nice. So what we are doing now is we want to figure out what the essence of NFT is in a nutshell. So a little bit of background, like why I'm presenting this topic to you. About a year ago, we had a client which offered a software as a service sales platform, which allows their customers to sell photographs, ebooks, music, and any other digital content that you can think of. And they were interested in the idea to use NFTs to offer like limited releases, alongside the digital resource. So you can still buy the photograph, and you can buy as many as you want as long as you have money, you get the copies. But you can also get a limited amount, 10, 100, 1,000, how much the creator decides themselves, of tokens, which are kind of, you get the photograph, but you get the photograph with kind of a signature for the artist, from the artist, which makes it unique, scarce, and kind of desirable to be owned. So these are what NFTs are on high level, but we'll get deeper into the topic. What we'll do is first we'll see what they are conceptually, then we will address the big question in the room: how can I steal it? Like, I suppose everyone has heard the news how much they sell for, and you tell yourself, okay, there are images on the internet. I copy images on the internet every day, so let's settle my children through college now, today. So I'll show you a demonstration of a theft. So yeah, hopefully you get rich soon. Then we will do something more creative. We will actually create a token, or so-called minting, which is inspired by the term from coin minting in the physical world. And finally, we will discuss a little bit the opportunities and problems for NFTs, so that you have kind of a broader perspective, not just technological, the technological side. So to understand NFTs, first we need to hit the term fungible. And I've been using NFTs for a year. When I hear fungible, the first thing I think about is food with mushrooms. And I love mushrooms. So unfortunately, this is not exactly what it is. The term comes from finance and economy, and this diagram should help us understand it. So focus now on the right side of the diagram, where we have the tangible resources, the physical ones that you can touch. So there in the top, we have a banknote, a gold bar. Those are fungible resources. What I mean by that? I mean that they're interchangeable. They're not distinguishable from one another to fulfill their purpose. You don't care if I give you a certain 20 lef banknote or a different 20 lef banknote. As long as it's 20 lefs, you're happy, right? You get free 20 lefs. So this is what fungible means. On the other side, non-fungible is like your apartment, your car. Sure, there are many other similar cars or apartments, but one is yours. It is specific to you. It is scarce to you. It has its own history. So if I swap your apartment right away, you will notice. It will not be indistinguishable for you. Maybe for the worse, maybe for the better. Depends on the apartment, I guess. So this is in the physical world. Now if we move to the digital world to the left, we see first the representation of a fungible digital resource. Bitcoins and Ether are an example of that. Again, you don't care if I give you one Bitcoin or another Bitcoin. You have Bitcoin. You see the price. You're relatively happy. And non-fungibles are NFTs. They're scarce. They have identity. And yeah, this makes them non-replaceable and interchangeable. So NFTs stands for non-fungible tokens. And when we say tokens, you can think of a reference to an object. In the physical world, when you play a board game, you can have a token that represents you on the board. With NFTs, you have a token that is for an image, as we'll see in our example soon. NFTs started with Ethereum about 7-8 years ago and exploded in popularity about 2 years ago. I'm sure every one of you have heard at least of them. And it was made possible by the Ethereum's capability to work with smart contracts. There was already a session about smart contracts. Hopefully you attended and you liked it, so we will not dive deep into them. But the important thing to know is that these are specific pieces of code that allow you to deploy functionality on the blockchain. So you can actually have state and have behavior there, unlike normal Bitcoin where you just track transactions. Like you track Petyo gives Yanshu 1 Bitcoin, for example, but nothing more than that. With smart contracts, you can do more. You can track state, you can track behavior, which enables NFTs. Then we have the blockchain benefits. Since it's on blockchain, it benefits from some of the blockchain's characteristics. So you have permanence. So this is a resilient distributed network. It's not, the NFT will not disappear if one node goes down, which is nice. Then you have ownership. You own your crypto resources, and this is nice, so you own your NFTs as well. There is transparency. You will see in the demonstration that everyone can go to the blockchain and see the NFTs there and track the transactions associated with them. And finally, there's the topic of security. The more eagle-eyed tennis players in the room will notice that there's an asterisk next to the name, and this is because security should be taken with a grain of salt. What I mean by that is you often see articles, NFTs are on blockchain, blockchain is secure. Sure, but it depends on the perspective. So for now, you can think about it like you have a bank vault. And sure, if your money is in the bank vault, it is secure. But nothing prevents someone from stealing them on the way to the bank vault, or actually replacing them with fake money, or as I saw in one movie, putting money in something combustible so they burnt overnight and in the morning there was nothing in the bank vault. The bank vault was still secure, like blockchain is secure. And those things quite literally actually can happen with NFTs, so one should be aware of them. We will talk a little bit more about them at the end. So we are in a mischievous topic, like stealing money from a bank. So let's see if we can steal an NFT. We already know what the benefits are of stealing one. So for this purpose, I have prepared an incriminating video of how one can do this feat. Yes. So in this video, we will follow up the steps. So hopefully afterwards, all of you can steal an NFT. I'm using a popular marketplace for NFTs where you can mint and trade NFTs. OpenSea is the name. And then I pick a collection. This is a collection for a comic book. I like the picture. This is why I chose it, nothing more specific. Ghost Comics. The artist created the first chapter of the comic book and issued 900 and something NFTs, like tokens, for that first chapter. We pick one. We pick number 788. It will be important a little bit later. We see the price. It's quite expensive, so fingers crossed we can steal it, right? Here we see some extra information, like attributes, metadata, as well as some technical description and some technical details. The important part is we see it's on Ethereum because we need to know where we are stealing it from, right? Ethereum is the bank vault in our metaphor. Here we also see a history of the transactions, who sold it, who bought it, who made an offer. At the root of this is the actual minting, the creation of the NFT. And if we follow the link, we go to the Ethereum blockchain. It is public, it is accessible. You can see the history of all transactions, including the transaction of the NFT. We confirm that this is for our comic book. We also see this ID here. It says ERC 728, if I remember, 21, sorry, with the specification for NFT. And also we can have visibility for the input data. In this case, it's not very useful. So far, we are still not stealing it. We want to get to the high resolution image, remember. We click on the link of the NFT itself, and the browser opens its representation. It says number 788. Let's correlate. Is this the one that we want to steal? It will be a nightmare to steal something else, like both a crime and we didn't get the result that we wanted. So it's the right ID. Here we see that it was minted with an initial transaction, and we have access to the smart contract that I mentioned. We can interact with its read-only API. So it's kind of an interface, and we can call methods and get the result. So we are interested in a method called token URI. If we enter here the ID of the token 788, did we steal it? Almost, but not yet. We see some jumbled data, which is actually base 64 encoded data, which if we copy and decode to see what is the content inside it, hopefully, still not an image, but it's a JSON document. And this document we can format to have a better look, and we're getting very close. So we see the name of the token with the ID. We see properties, description, and we also see a link to an image, which is hosted somewhere publicly. So fingers crossed, we take the link, we go to the site, we hit it, and voila, we got to the original image with the highest quality it was created with, and we kind of stole the NFT. So we got the image itself. But what we got is an anonymous image, like which you can copy as much times as you want. In essence, on the blockchain, it still says that the identity of that image is owned by a specific person who bought it for God knows how much money. And we cannot touch that part. So maybe we stole, we got to the image, but we didn't change the ownership. We didn't really steal it. And from my perspective, stealing is not the right question. So yeah, it's not the perspective that you should take about it. What is more interesting for me is the next question, which is how you can create one. How can you mint an NFT? And as IT people, we are interested in creations. So we will go through the steps of doing it, so you have a better perspective of that as well. I wanted to have even a more technical demonstration there, but yeah, the time is limited. So what did you need to do? First, you need to pick a blockchain. Ethereum is a popular choice. Everyone, I'm sure, has heard it here. There are other blockchains as well that support NFT. Solana, Clayton, Cheo, Polygon, to name a few. So you choose to use it. And what you're using when you're using the public Ethereum is what is so-called mainnet. But when you develop, you don't want to hit the real mainnet because that costs money. So to feel safer, what you would use is the testnet, which is again a public network, which you can access, but it's limited with some more restrictions. And less nodes, but still quite sufficient for your needs to test your application. And this is what we did in that project as well. Currently for Ethereum, Gyorli and Sepolia are popular test nets. Well, last year there were a few, but actually last week one of them was made read-only, so quite a dynamic field. Then you need a wallet. The wallet basically will give you your public address where your NFTs will be associated. So it will be like a real wallet where you put your virtual, like digital NFTs. It will also hold the password that gives you security and that blockchain security aspect that we can discuss later in the questions if you want. And you don't need to add crypto to the wallet in order to pay. Whenever you do something on Ethereum, you need to pay for the transactions, for the cost of those transactions. And yeah, you need to charge your wallet with crypto for that purpose. Now we move to the smart contract. We will not dive into the smart contracts themselves because it's quite a time-consuming topic. But I wanted to show you one just so you have seen it and have a first image of it. And the impression that I want to leave you is that first, look, like it's quite short. Like it's not a big deal, at least in this representation. Not that there are not complicated and troublesome smart contracts that need to be tested, etc., as the colleague shared earlier. Why this is possible is because we are actually using a library called OpenZeppelin, which gives us a default implementation. The smart contract, in essence, is an interface which allows you to interact with it and kind of give it commands and react to specific events. And OpenZeppelin provides a default implementation. So actually, we need to just provide our custom logic in the mint NFT part. It also has a specific extension on the second highlighted line, which is to store URIs, as we want to store the reference to our NFT. And next, we have the mint NFT method. We specify a recipient and a token URI, as you saw in the example that we demonstrated. And from there, the other two highlighted methods are actually internal. We are using what we inherit from the source specification on the top, implementation on the top, and reuse them for our purposes. So this is an example of a simple smart contract which you can set up. There are many more on the internet, and yeah, they should be stable and tested in order to be reliable. Then you have the question of the content itself. Like in the example I showed you, the image was, we accessed it via an HTTP request, you probably noticed. And this has two major problems. I guess you already think about some of them as well. First, that server might go down. If it goes down, yeah, the NFT still exists and is resilient on the blockchain, but you cannot really get to the image itself, which steals a little bit of its charm. Like you still have some bytes somewhere, but it's not the same. And secondly, someone can go to that HTTP server and can replace the image. You have the same name, the URL works the same way, but it's a different image itself. If you want to address this, you can do it via IPFS. This is a distributed file system where whenever you put something there, it's resilient because it has redundancy in multiple nodes. So yeah, one node failing is not a problem for us. And more importantly, the reference that you get, this IPFS URL that you see at the bottom of the slide, is tied to the content. It's kind of linked to the hash of the image in our case. So if the content changes, actually it will be a different URL, like URI. And this ensures that you cannot kind of swap the image in the case that I showed you. And for those of you that are proactive, if you scan the QR code, you can actually see a teaser of the NFT that we are minting virtually now in this session. OK, to do this, next you need to use an API. This is the easiest option. We deal with APIs on a daily basis. So whenever you want to mint an NFT, you can do it differently, but API is the easiest option. For Ethereum, Alchemy is a popular choice. It offers a nice REST API. Tatum is the one that we use because it offers kind of a meta API and gives you flexibility to switch between blockchains. It's kind of more abstract and gives some extra features. But besides that, it's like any public service that you use either the free option or a subscription. You get an API key and you make the calls. And the calls themselves are nothing too exciting. We show here two API calls. The first one deploys the contract, like an example contract like the one I showed you. This one is deploying a predefined one because this is the Tatum scenario. So we need to provide which is the blockchain, because as I said, Tatum supports both. You specify a name of the contract, and you specify the private key. Why? Because you need to pay for the transaction. And this is the private keys access to your wallet, so you can pay. Once you create the contract, you get an address, which then allows you to make invocations, like calls to mint your NFTs. And on the right side, we have an example of those calls. So we again specify the blockchain. We give an ID to our token. We give to whom the address of the wallet where the token will be stored, so you keep it in your wallet. The address of the contract that will do the job. Here it's a parameter. And we have the private key for payment as well, and our URI. And in this case, we did a best practice. We did it via an IPFS link, not just HTTP. Yeah, and once we do that, voila. We actually minted our NFT step by step. We get a reference to the transaction itself, which is shown here at the bottom. And if you scan the QR code, you actually open the NFT in the browser via an explorer for the blockchain. And on the left, you actually see it, the similar technical details to the ones that I showed in the demo. And you now know that our NFT is actually the image of this year's ISTA conference. One thing that the more eagle-eyed of you will notice is that this one, for variety, is not minted on Ethereum. It is minted on Petyo, which is another blockchain, so you can see it there. What lessons did we learn from our experimentation with NFTs for our client? There are many, but the ones I want to highlight are, first, Ethereum is fancy, but it can be expensive and slow. Here you see an example that the cost for minting one NFT can vary between 10 and 100 euro, and I have seen online even larger variations. We just didn't experience them. And it also might take minutes, which means you need to plan it in your architecture, in your design. Like it's not something that you expect synchronously. But there are alternatives. We went with Petyo as well. What we did was we actually, based on the business use case, supported both. For more fancy images that are expected to sell for thousands, this cost is not a big deal. But for something smaller, cheaper, the other option is nice. Like you allow the people to dab their finger in NFT without robbing the bank in the process. Next, you will notice if you search for this that there are a lot of sales materials online with a lot of buzzwords, but not that much good developer information. The API, this is getting better. Like last year, it was not as good. This year, it's better, etc. But the APIs that I referenced, like Alchemy and Tatum, have quite nice documentation with online materials, Discord channels where we communicated with the developers, so quite nice. And then it's a dynamic area. And this has many implications, like the prices are volatile. Testnets get deprecated, as I mentioned. One happened last week. New blockchains are introduced like yearly almost. So be prepared for that aspect of it. And now for the final part, I want to discuss some kind of more general topics associated with NFTs, a little bit to exit the technical part, to see what are the opportunities and problems there. I don't exhaust the topic because the time is limited, but I want just to briefly mention them. One is that they introduce uniqueness and scarcity for digital resources, so they're quite useful for collectibles. If something is scarce, and you can own it, people will have a desire to own it themselves. It also has the potential for an investment, but again, take it with a grain of salt because it's quite a hype market, it's very volatile, so it depends. Like if you have proficiency in the area and think you can distinguish the good from the bad, you can try, but I personally am more conservative about it. There are other problems, like I mentioned the illegal activities earlier. One part of it is the example with the link. So everything that is not on the blockchain, like the link on HTTP to a different resource, or maybe an NFT promises you that if you go to this bar, you get free drinks. It's possible, people can support it. If it is off the chain, it is not really guaranteed, so it might disappear. This is called rug pulling. And there are other problems there. Yeah, we can discuss them afterwards if you wish. And finally, the intellectual property is one I want to highlight. Some people quote NFT as solution to problems with intellectual property, but that's not really the case. Like, when you get an NFT, you don't get actual rights of the digital resource. So if you take my NFT or Istas NFT and you put it on billboards and you start getting money out of it, in the general case, you can be sued. Like, there is no protection. There could be, but usually there is not. And with that, we finish our talk, and I leave you with a summary. So NFTs basically allow our poor Smigo to not have the One Ring itself, but to have a reference, a token to its digital representation that is stored in the distributed database. So this is a technology that is new, quite modern. It has potential, but it also has kinks that need working out before it matures more. So if you have any questions, I'll be glad to try answering.
We have time for one question. OK, we have one there.
There were some slides mentioned the value of NFTs, but what is the real value of owning or creating them just to put TV representation on the wall in home? Or?
Well, it is something that is still being clarified, but it allows you, for example, like there are several scenarios that I didn't dive into, but one aspect of it is it allows you to make something scarce. Like normally an image can be copied multiple times, but when it is a reference of it is stored on the blockchain, it becomes scarce and kind of unique, which adds an extra property to it. How much value you put on this is subjective. Like this is something that kind of depends on the community itself. There are other parts, like there are tidbits there that technically would allow an artist, when that NFT is resold down the line, if the smart contract allows it, they will get kind of royalties, so they can get extra returns on them. As I mentioned, you can use it as a speculation on the market, like you would buy a painting and you hope the price will inflate. But all those come with large asterisks next to them. If you want, we can discuss them afterwards if you're interested in the area. And yeah, before we close, if someone scanned the QR code, it's actually access to the slides themselves, and you guessed it, they're distributed and stored on the IPFS.
OK, thank you.